Let us explain what happens in the cranial part of the gastrointestinal system. The first scheme will be a lateral view on the head region, where a surface head ectoderm invaginates to form the embryonic oral cavity called stomodeum. To which the endodermal foremost part of the GIT is attached as the embryonic pharynx. Inside there will be the brain vesicles, as we already know, the prosencephalon, the mesencephalon, the rhombencephalon, etc. And the contact between the ectoderm and endoderm is the oropharyngeal membrane. So this will be the head ectoderm that invaginates here to form the stomodeum, just another word for the embryonic oral cavity, which is, as we can see, lined with the ectoderm. And so all the derivatives of the stomodeum will be also of ectodermal origin. It's separated from the endoderm by a thin and temporary oropharyngeal membrane that breaks down after or at the end the third week. This is already the pharynx lined with the endoderm. Here there will be the brain vesicles, the prosencephalon, the mesencephalon, and the rhombencephalon that have been already discussed in the development of the nervous system. Now we need to have a more closer look to this region of the embryonic pharynx to explain the pharyngeal clefts, the ectodermal pharyngeal clefts, and later on also the endodermal pharyngeal pouches. Let's make a frontal section for that purpose, and it will be the frontal section through the region of the pharynx. We would see that the tissues form so-called pharyngeal arches there. So there will be a series of arches that are separated from the other arches by invaginating ectoderm. So this is the arch number 1, 2, 3, 4, and 6. The fifth arch is not distinguishable in human embryos. Here will be the oropharyngeal membrane, meaning the border between the ectoderm and the endoderm, and on the other side the situation will be symmetrical. First, second, third, fourth, sixth arch. Now I will also add the endoderm of the oropharyngeal membrane, and the endoderm also forms these structures called endodermal pouches from the inner side of the pharynx. In some vertebrates, like in fish, in sharks, these clefts and pouches, they perforate completely, making the pharynx communicating with the surroundings. But that's not true in mammals. So let's label the arches, okay? pharyngeal arches. The first, the second, the third, the fourth, and the sixth. The fifth one is not distinguishable. Each arch contains one of the cranial nerves the first arch containing the trigeminal nerve, the second the facial nerve, the third the glossopharyngeal nerve, the fourth and sixth the vagus nerve, and also a significant arterial branch, which is one of the aortic arches. We have already discussed the series of aortic arches when we discussed the development of the circulation. Also, in the arch we can find the mesenchyma tissue, which is mostly of neural crest origin, and this mesenchyma will give rise to structures such as muscles, bones, bone elements, or pieces of cartilage or ligaments. Of the region of the jaws and pharynx. So that will be the oropharyngeal membrane. And to establish the terminology necessary here, this invagination of ectoderm is the ectodermal cleft. Pharyngeal cleft, and this invagination from the inside, from the pharynx, is the endodermal pharyngeal pouch. In the first scheme, I would like to explain what happens in the region of the ectoderm. Then we will make a special scheme on the about the endodermal side. So, the ectoderm. As this region undergoes some remodeling, I will include the structures before remodeling to the left side, and the right side will show the structures after remodeling of this anatomical region. Before remodeling, the first arch has projections called auricular hillocks. Then comes the first ectodermal cleft, especially deep, and also there are processes called auricular hillocks on the second arch. Then comes an ectodermal structure called the operculum, which kind of grows over the adjacent clefts and arches. So this is the third, the fourth, and sixth arch. I will add the endoderm as well. Here will be the oropharyngeal membrane. Now I'm adding the endoderm, which also sends a projection here. Second arch, third, fourth, sixth. So which structures appeared here? So-called auricular hillocks. There are 3 pairs of the structures, so 6. And what is the first ectodermal cleft here? This will be the first cleft. Now this structure emerging here is the so-called operculum, and the space that is below the operculum, the temporary space, is called the cervical sinus. Cervical sinus. And the cervical sinus will later on adhere to the surface ectoderm and fuse the space, so the operculum will close the space. So how does it look like after remodeling, and what comes out of these structures? The auricular hillocks will fuse to form the external ear. The first cleft will become the external acoustic meatus. And the closed operculum will cover the lateral side of the neck region. Here will be the auditory tube. And this will be the tympanic membrane, actually. So the first cleft becomes the external auditory meatus. This will be the external ear. The pinna. Now this is the closed operculum. It's fused here. Therefore closing the cervical sinus. If not, if there would not be, it would be failure in this closure, there could be cavities persisting here called lateral cervical cyst. In the region of the sternocleidoid muscle. But normally there are no cysts. That's already kind of pathology resulting of an incomplete fusion of the operculum with the cervical sinus. In next scheme we will discuss separately what becomes out of these pouches. Let me label the oropharyngeal membrane here. So this is before and this is after remodeling of this region.